All right, good evening and welcome to today's session. So, like I promised last time, we are going to be looking at what we were supposed to do on our last session, which is making use of our t-tests. So, what we will do tonight, therefore, we will go through the explanations of this here through some of the exercises that you perhaps have done before, or maybe what was in the assignment as well, so that we see how we are supposed to tackle these questions. All right. So this is the November 2022 paper, right? And then this is what we have on the paper. We've got section B, all right? We'll be doing the stuff that's on section B. So particularly evaluating the regression with respect to each of the individual coefficients, clearly stating the appropriate null and alternative hypothesis, t-values, decisions, use a 5% level of significance for testing. So this is what we are going to be doing. And then test the regression for overall significance at a 5% level of significance. So this is the last part that we will be doing there. And then we'll take a look at the other one on the other question. So I see we are just three of us here. So I was hoping if we can at least engage so that I can see if we are following each other, particularly when we are moving on to the next example. So I want to see if we are all following suit. All right. So in dealing with a question like part A here, where we are evaluating the individual coefficients and then clearly stating the null and alternative hypothesis, what we need to do, I think an easier way to present this would be the way we did it in the assignment, and this is what you get here on the study guide. You get that right there on the study guide. And so this is the format that we basically work with, right, for us to be able to get full marks. So you basically come up with a table like that. Of course, you want to eliminate or to remove this part here for marks. We don't use that. Okay, so you want to have your x variable and then expected value of the coefficient, and then the null and the alternative hypothesis, and then the t value, and then you then come up with your decision based on your evaluations of that. So this is what we are going to be doing. So because we are not going to draw the table tonight, but we'll basically fill it in. We are basically going to be filling in the table. Okay. Nobody is saying the environment is very noisy. Okay, no, it's fine. It's okay. All right, so let's see what's going on here now. On our question, right? This is our question. Right, here is our question. So these are the variables here on the first column. All right, so we have the constant. First of all, okay, let's read the question in full. The dependent variable, which is expenditure on housing, which is given here as HSE, which is the expenditure on housing. All right, and then our sample is 36 households. All right, so our constant, which is the intercept, is given here as 20. This is our constant given there as 20, right? And then the x variables, some of the explanatory variables or the explanatory variables are given here below, right below the constant. So the first one is INC, which represents household income, right? And then we have that coefficient there of 0.28, and then NP, number of persons in the household, it has a coefficient of 24, and then RM, the number of rooms in the house, it's minus 18, and then URB, 1 if the house is in an urban area, and then 0 otherwise if it's in an area that is not an urban area. So this would be an example of a qualitative variable. Okay, and then CON representing the condition of the house on a scale between 1 and 5. So 1 being excellent and then 5 being very bad. Okay. All right. So what we are trying to estimate here is the expenditure on housing. Right. Is the expenditure on housing. That's what we are basically trying to estimate there. So the first thing that we therefore need to do in deciding on this table, obviously over and beyond our calculations here of DFs, we need to find out what our expected signs are, or decide what our expected signs are, because that basically determines whether it's going to be a one-directional test or a two-directional test. That's what that basically determines for us. We are going to see how that works shortly, right? So let's have a look now and see, because we are trying to evaluate now the expenditure on housing, right? We are trying to evaluate the expenditure on housing. So what would be our expectation now in terms of the household income, the relationship between the household income and the expected expenditure? So here we can reasonably expect a positive relationship, right? We can reasonably expect a positive relationship. So we can expect that whenever the household income goes up, the expenditure on housing can be expected to be just as high, right? We can basically expect that too. Let me just, I think I just got disconnected there. All right, let me work on the connection there quickly. All right, yeah, I think I'm gonna be back in just a second. I'd actually connected to the wrong Wi-Fi. Okay, we got it now. So in terms of the expected relationship now, this is where we are coming in to say, okay, the expected relationship here is positive. Number of persons in the house. So we can expect that when there's an increase in the number of persons in the house, there's also going to be an increase in the expenditure on housing. Right? So we can also expect a positive relationship there. And then what about the number of rooms? Number of rooms. Number of rooms. What expectation could we have? I don't know if I could ask you, Sibusiso, on that one, or if you're also not in a good space to talk. Are you in a good space to unmute yourself? Oh, okay. It's fine. Not in a good space. All right. So, okay. Right. I'm gonna take it on that one. Oh, okay. So this one. It's fine. It's fine. So I'm gonna take it on that one. It's fine. I'm also being interrupted here with a phone call. Okay. In class will call. All right. Okay. That's understandable. So here I don't know, but from my take on this one here, if you look at number of rooms in a house, you could expect that if the number of rooms are obviously increasing, you can expect that your expenditure on housing is also going to increase. I think that would be a reasonable expectation there. So, which is why I would go with the positive on that one. And then urban area and otherwise, this is also a positive relationship. And then the condition of the house, right? The condition of the house. I would expect obviously a very in this instance, if you look at the scale that's given, right, they're saying if it's 1, right, if it's a scale of 1, the condition of the house is excellent. And then if it's on 5, it's very bad. So meaning that if we are decreasing here, it means that we are moving towards excellent. I don't know. I thought they would have done it the other way around. So if they had obviously done it the other way around, I would have gone for a positive relationship, right? Expecting that if the condition of the house is excellent, then the expenditure on that housing is also high. But in this instance, you can see that this is moving in a different direction. It's moving from 5 to 1. So it could have been a mistake on their part, but we will take it as it is. So in this instance, again, we are expecting a negative relationship. So a negative relationship on RM and the RM and a negative relationship on CON. That's the expectation there. So this is what you are seeing there. So this is how you basically fill that in. So you take up your X variable, you put up your X variable there, and then you can put the expected signs right on the next column there. All right. And then as for this calculation here, N minus K minus 1, which is DF, that's our degrees of freedom. So they basically assist us in calculating the critical value, right? In this instance, they assist us in calculating the critical value. So how do we calculate that now? So the formula is given as N minus K minus 1. So we need to define now what N is and then what K is. So N, we already know that as sample size. So our sample size is 6. So this is equal to N. And then K is the number of coefficients excluding the constant. Right? So in this instance, our K is going to be 1, 2, 3, 4, 5. So our K is going to be equal to 5. And then this one here that you normally see on the calculations, the one that you normally see on these calculations is representative of a constant. Right? It's going to be representative of a constant. And this, by the way, is on the static height. Is on the static height. So if you want to know the best way of answering these questions, these UNISA questions, you look at how they answer the questions on the static height, and then you follow suit when it comes to your assignments and examinations. Right, so which means our degrees of freedom is basically going to be N minus K and then minus 1, which is the constant there. So we already said K is 5, which is 1, 2, 3, 4, 5, which is the number of independent variables, exponential variables, right? And then 1 is 1 for the constants there, right? Which sections on the study guide and on the textbook? Okay, I'm gonna go to the textbook. This here is the textbook, so I'll go to the textbook and then you see. I think it should be chapter 5 thereabout. Then you will see that on the study guide as well. All right, so now we'll be done with our expectations. Then maybe let me put that on Excel. Let me just put that on Excel. But I was trying to not type too much today, but I think it would be very much helpful if we can type this in terms of us remembering what we are supposed to do. Let me just put it down here. All right, so I'm just going to copy the variables here onto the Excel sheet. That's what I'm doing on the Excel sheet that we are going to be using. And then we can put in our expected signs. But, okay, I'm just going to make also a slight adjustment in terms of our expected signs. So this actually comes in handy with our class, but I would have wanted to start off with this one here, but it's fine. All right, so I'm just taking the X variables here. I'm just taking the X variables there. All right, and then I'm gonna put up the expected signs. Right, let me share what's on the Excel sheet. Right, you see what I've been up to. All right, I'm still copying the stuff here. Let's x variable, and then we want to have the expected sign of the coefficient there coming next. All right. All right, and then the null and the ultimate hypothesis. So these things are quite easy, by the way, and I'm hoping by the end of the class, you will realize that this is actually a lot easier than what we make it to be, and of which you will get an examination question on this, and then this is a very good part of the exam for you to totally get everything correct. All right, so this is what we have there. All right, so we'll put our degrees of freedom here. So this is going to be, we said it's n minus k minus 1. So ours was 36 minus 5 minus 1, right? That should give us 30. Right. Let's put this like that. All right. All right, and then we'll decide. I think this is just about it here. All right, back to our question. All right. May you please give us a list of the sections on the textbook and study guide which we could focus on to get a better understanding of the work. Personally, I understand a little bit. Okay, that's fine. So we are going to be there on that one. All right. So on the study guide, this is the study guide here. This is the study guide. So you are learning unit number 5, basic statistics and hypothesis testing. So I believe that should be on, as well as maybe chapter 5, but we will see when we get to the textbook. All right. But remember here now, in this instance, what we're doing is applying this here. We want to deal with these calculations here, filling up this table. So, and I already indicated that this table you deal with when you are supposed to be making decisions regarding your t-tests. So that's where this table comes in. All right. So we are seeing now how that can be applied in a question like this. Right. So you basically need to come up with this table here. So we're still on the expected signs here. So we're still on the expected signs. So in terms of expected signs, we are looking at the relationship between the dependent variable and the independent variable, whether you expect it to be a positive relationship or a negative relationship. That's what you want to look at there. And then we say it on the first one, we can expect that as incomes of households go up, right, we can expect that the expenditure on housing is going to go up as well, right? That can be a reasonable expectation there, right? That can be a reasonable expectation. So which means we can therefore come and fill this up here, and then we can say expect positive. Expect, right, expect positive. So this is in terms of our coefficient, right? Which basically describes the direction, which basically describes the direction there. All right. And then the number of persons also agreed that NP is going to have a positive relationship. So on the sheet there, I'm just going to copy that onto the next part. All right. And then the number of rooms, right? The number of rooms, we also said this is going to be positive, right? We said we expect a positive relationship there, right? And then in terms of if the house is in an urban area, and then we also said this is positive, we expect another positive, right? And then the condition of the house, here we said we expect a negative, right? So I'm, by the way, typing these things on Excel there. I'm just going to show you what I'm typing shortly after this. But it's just basic filling in. This is just basic filling in. Right, there you go. This is what I was typing there. All right, now we need to deal, therefore, with the null hypothesis and then the alternative hypothesis. So now we are learning how to identify or how to come up with a null hypothesis, which is given there as H nil, and then HA giving us for the alternative hypothesis. Right, so how this one works now in terms of the null hypothesis and the alternative hypothesis. You are basically looking for, in terms of the null hypothesis, right? You are basically looking for what is not expected. So in other words, you are moving in the opposite direction. Right? You are basically moving in the direction that is opposite the one that that represents your expectations that you've put down there. Right? That's what you are basically doing there. So, for instance, if we're expecting a positive sign here on our coefficient, then it means our null hypothesis, therefore, should be anything that is 0 or negative. That will be representative of our null hypothesis. So this is, therefore, how we are going to write it. So H nil, let me write that as HO, like that. Right? HO. So we are dealing with the coefficients, our beta coefficients. Right? So we are therefore going to say our beta coefficient, because we don't expect it to be positive, right, in terms of the null hypothesis. So if it's not positive, then it's either equal to or less than 0, right? That will make it negative, right? That will basically make it negative then. Right? Why do we expect negative in the condition of the house? That's a very good question, right? Because I would have ideally expected a positive there, but if you look at how it's written here, so they are saying the condition of the house, it's on a scale of 1 to 5. It's on a scale of 1 to 5. So if it's 1, then it's excellent. Then if it's 5, then it's bad. So I don't know, but from my expectations, I would think for an excellent house, the expenditure on that housing needs to be higher. I believe that the expenditure on that housing needs to be higher. And then for one that is bad, the expenditure on that housing needs to be lower. Right? So if you look at how this has been set up from 1 to 5, then if you compare it with what we have there on our expenditure, they look like they are moving in opposite directions. Right? It looks like it's moving in opposite directions. So in other words, where it's excellent, we are moving backwards, right? From 5 to 1. Here, it's increasing. There's an increase in the expenditure. It's moving in the opposite direction. So which is why my interpretation on this one was a negative relationship. I'll therefore, based on what's given there, I'll opt for a negative relationship. But had it been the other way around, we'd expect, of course, that bad would be 1, right? And then good would be 5, or excellent would be 5. Then in those instances, we'll then expect a relationship that is positive, right? So that was the interpretation for that one there. All right, so we are done with the first null hypothesis. Let's take the alternative hypothesis, which is going to be HA, right? So our HA is therefore what we are seeing here, right? We expect our beta coefficient to be over 0, right? So if our beta coefficient is over 0, we are basically saying it's positive, right? Yes. So if the scale was swapped around, would we also say we expect it to be positive? Yes, that's correct. I actually suspect that there was a mistake on that scale. I just don't know, but who would put a scale like that? It just doesn't sound right, but it's fine. We'll work with what's given there. Right. So now, this is our alternative hypothesis now, where we are saying our beta coefficient is positive, right? Which is what we expect. So remember, our null hypothesis, which is our H naught there, basically describes what we do not expect, right? Which is going to be opposite to what you expected there. And then our alternative hypothesis is therefore what you expect there. So we simply do the same for all those. So you will realize that for all those where we are expecting positive, we should pretty much have the same, we should pretty much have the same things written there. Right? So what we have there should apply wherever we're expecting positives. Right? Wherever we're expecting positives there. And then if it's negative, then our null hypothesis will therefore be different. Right? It's actually now moving in the opposite direction, right? It's now moving in the opposite direction. We are coming up with different conclusions now. Right. Right. So if we are saying we are expecting it to be negative, so what we don't expect is for it to be equal to or greater than, right? Or greater than 0. So that would make it positive, right? And then our HA is therefore going to be given as, okay, let me correct that one. Our HA now is what we expect, right? Oops, sorry, our HA is what we expect now, which is going to be a negative there. So this is actually fairly easy for you to get. Probably the most difficult thing would be coming up with the expected coefficients. I think on the last class, when we spoke about this, we were saying that's why you basically need to have a sound understanding of the subject matter, right? A sound understanding of the subject matter. Like for instance, when we are talking of expenditure on housing, what are we looking at? We might want to first of all define what that is so that we can understand what this is all about. Because this is going to assist us now in terms of our expected signs. Right? Basically going to assist us on our expected signs there. You see. So, but then normally I don't think they'll give anything that is really complicated, right? And then we'll deal after this, we're going to deal with a situation where, let's say, you are unsure of the signs. What do you do in those circumstances when you are not sure of what sign to use there, right? What you would do. And then I think Mbali, are you following so far? Because if you can unmute yourself, okay, or even on the chat box, I would also love to engage with you on the chat box if there is anything that you are misunderstanding there. But basically, we're saying we are following through on the format for this. This is how we basically work with that. So right there. So on this here, why that typing is like this in particular is because maybe it's on Excel. If you are doing this on Microsoft Word, you will have a sign, a proper sign that can show that this is greater than or equal to, right? You can actually type that out. All right, now we can calculate the t-values, right? Which is also another easy thing to do. So in calculating the t-values, you are taking the coefficient as given, and then you are dividing by the standard error. So coefficient divided by the standard error, coefficient divided by the standard error, just like that. That's how you are getting your t-values. So this is what you write for your t-values. That's there under the t-values. Right. Let's see what we get on ours there. All right. All right. So let me share the Excel sheet there and then minimize so I can be able to see what's going on the other side. All right. So on the calculation here, I'm simply taking the coefficient value, right, for household income, so which is given as 0.28, and then dividing it by the standard error, which is also given there as 0.12, right? Then we get our 2.333. Okay, and then on the next one, our NP, we are given there as 24. So all these I'm fetching, by the way, from, I'm gonna show you again where I'm taking this from. So mark that it was 24 divided by 14. Let me just show you where we are pulling those amounts from there. Right, that's your 24 there divided by your 14. That's where we are getting our amounts from. All right. And then on our RM, the value there is minus 18. And then we are dividing by 11. Right. And then our URB is given as 44. So you take that 44 and you divide by 22, the standard error. All right. That gives us a minus 2 there. Okay, and then all right, so the question now is that I'm gonna get your question now. Okay, so the last one is 12 divided by 10. 12 divided by 10. Yes, the answer to that one is yes. The question is, are we always going to be given the numbers for the variables? Those numbers are coefficients, right? Or are there instances where we would have to calculate them ourselves? Nah. Maybe if it was an assignment, you would have been asked to calculate them yourself. So remember what we did on the first assignment where we ran a regression model, right? So when we ran that regression model, it gave us the beta coefficients. So the beta coefficients are basically that there. Right? If ever you are asked to calculate them, you'll be making use of this formula here, right? For the beta coefficient. And then if it's going to be a multivariate one, like the one that we're dealing with, then you'll be making use of this formula here. I think we have these formulas on the other notes that I sent in the group. But by the way, it's highly unlikely, right? It's highly unlikely that it's going to get there. But if it does, we are simply using this formula. Then if you are going to be given a spreadsheet, then you just run your OLS on that. You run the regression there, you will get the coefficients. And then you take the coefficients as they are, then you are dividing by standard error. So when you are running that, whenever you are running that on Excel, it will give you both the coefficient and the standard errors. So which means when you are going to be doing your tests here, your 5% level of significance using your t-values, you are simply dividing the amounts as you are seeing them there. So it's not that complicated, right? Oh, okay. And then before I go back to the spreadsheet, so now that we have that, one more thing that we need to calculate now, we have to calculate our critical value, right? Our critical value. So our critical value, it's more like our pass mark, right? It's going to assist us in making this decision here, right? It's going to help us in making this decision. And coincidentally, I think if you look at our, we'll check that very well, but if you look at here, our calculation for okay, our degrees of freedom, if you look at our degrees of freedom, they pretty much look the same. I'm gonna check that again from our calculation. All right, but I'm gonna show you how we get that. Right, but we are basically here now. Right, let me copy that and then see what we can do about that. So I'm simply copying this. I'm just lazy to type, but you can simply type this and put it over on the other side. Right, but I'm just gonna put an interpretation to that. Most important, I'm gonna put an interpretation to that. All right, so we are basically doing a t-test. We are basically doing a t-test. So this is why we are seeing this t there. And then 30 here represents the degrees of freedom, right, which is what was calculated there, right? And then 5%, we are doing it at 5% significance. And then this one here is a one-tailed, represents a one-tailed test, meaning it's one directional. So I'm just going to explain what we mean by one directional and what we mean by, if it's not one directional, what would it be? So that's what we are going to be looking at there. So if we move down now to our question, let's see what we have there. So n minus k minus that, I think this basically gives us 30 as well, right? Gives us 30 right there. So let's see now how we can get our critical value. So we are doing a 5% significance test. So at the back of every examination paper, you are basically going to be having these tables here, right? You are basically going to be having these tables here. So what are we looking for? So we are dealing with a one-sided test. So this is where we are. So that's what you are looking at there. One-sided test. How many degrees of freedom? We say it is 30 degrees of freedom. So there you go, 30 degrees of freedom. And then level of significance is 5%. So we are looking at that there from the second column. So which is why you are seeing 30. And then this is the value that you are taking, which is 1.697. Right, 1.697. So that's the value that you see where? That's the value that you see there. So coincidentally, it's the same value that they were using there it's the same value that they were using there for the example that we have. But it could be different. So if it's 29 degrees of freedom, then you would have your 29 there. And then this is where you come and check again. Instead of looking at 30 there, instead of looking at that 30 there, you'll be looking at 29. 5% level of significance would be on 1.169. So that's how you identify that there. All right. How did we know we are dealing with a one-sided? Very good question. Now is the right time to answer that. So if it's not a one-sided, it's going to be a two-sided. So a one-sided, where we decide whether it's a one-sided or a two-sided test is here, right? We are deciding based on this part here. So this is a very important part here in coming up with, in assisting us to come up with that decision. Let me just put that in red there because it's very important. So a one-sided test is an instance where our expectation is in one direction. Like in this instance, we're expecting our sign to be positive. So which is the sign of the coefficient or the value of the coefficient, we're expecting it to be positive. So in that instance, we're expecting it to be one side. Suppose there was an instance where we were not sure, right? An instance where we are not sure. So we are going to make that adjustment here. Remember on this one here, where you said it could be positive and I said it could be negative. So there, let's just say now we expect that one to be we don't know, right? We don't know. So which means it can either be positive or negative. So in those instances, it becomes a two-sided. It becomes two-sided because it can either be negative and it can either be positive, right? So in that instance, there isn't enough data to corroborate the expected signs, right? So we are going to make an adjustment on that one much later. Right, so this is how now we are on the decision. Now we are on the decision. So what are we doing now in terms of our decision? We are looking at the absolute values or our absolute t values here. So in terms of absolute values, we are ignoring the sign, right? We are basically ignoring the sign, dealing with the absolute value, right? The absolute number. That's what we are looking at. So if the absolute number is bigger than the critical value here, or if the absolute t value, all right, so the last one is a two-sided because we are not sure of the sign. We can make it a two-sided, yes. We can make it a two-sided. So we'll make it a two-sided in the end, but I would have gone for the one that I gave here, right? But we can as well make it a two-sided. Right, so now we are looking at this value here, right, the t value, our calculated t value, and then we want to measure our calculated t value against the critical value here, right? Basically looking at which one is bigger and then which one is smaller. That's what we are basically looking at. So if that calculated t value is bigger than the critical value, what do? We reject the null hypothesis, right? And then if it's greater, we do not reject the null hypothesis. That's our decision. So how are we going to write this? Then we can say 1.697. This one is smaller, right? Smaller than 2.333. So what do? We reject the null hypothesis. What is our null hypothesis? We reject the null hypothesis. That's a very easy decision to make. So that's what we are looking at. But we are not just looking at that now. Not only are you looking at the absolute values, by the way, you also want to look at if there is a correspondence between the expected value that you have there and then the value of your calculated value here, which is 2.33. For instance, your 2.33 is positive. What's your expectation? You also expect it to be positive, right? So which means you can therefore proceed to reject the null hypothesis. Then if you look at the next one, 1.69, Excel is very smart, you see, it's doing for us now. We are going to assess them. Let's see. So 1.69 looks like this one is less than 1.79. So what do? We reject the null hypothesis, right? We agree on that one. It's fairly easy again. And if you look at the expected signs, then we are saying it does not have to be, sorry, it has to be rejected. There is a correspondence there. Right. Then if you look at your RM now, the value of our RM is actually in the opposite direction, right? Right. The value of our RM, right, let's remove that positive there because we are dealing with an absolute value, right? We are dealing with an absolute value. So is 1.697 smaller than 1.636? No, right? So this sign is in the other direction there. So given that, what do? We fail to reject, or we fail to reject our null hypothesis for two reasons, right? Reason number one, our critical value there, 1.697, is greater than our calculated value in absolute terms. And then if you look at the signs now, we are expecting a positive sign, but this is a negative sign. So we do not reject the null hypothesis, right? We do not reject the null hypothesis there. So what do we mean by this? We are saying there is a possibility that our beta coefficient is 0 and or less than, right? Or less than 0. In other words, negative. There is that possibility there. So what's the significance of all this again, now that we are here and we're dealing with this, by the way, at a 5% significance level? If you are saying your beta coefficient is 0, what does it imply there? What's the implication of that in terms of our equation? Because it's a coefficient. So if a coefficient is a non-zero coefficient, is not equal to 0, it basically means that whatever the coefficient is, it has an effect on your y variable. It can either increase or decrease your y variable. But if it's 0, then there is no relationship between those two variables at all. So that's what we are saying. So now that this is not statistically significant, it means that there is this possibility now that this can be equal to 0. In other words, the relationship can be an opposite relationship, or there can be no relationship at all, right? Remember the background of this, why we are doing this. So we are doing this now. We have run a regression model, right? And in our regression model, remember initially we were looking for X variables that have got an effect on Y, that actually cause changes in Y, right? Remember, Y is the explained variable, right? It's the variable that we are trying to explain. Then we are saying variations in Y can be explained by variations in X. And for that to be possible, then the coefficient of that X should not be 0. Otherwise, if it's 0, it means that those have got no relationship at all. You see? So that's what this means here. All right, and then what about this one here? Let's see what the case is. All right, so on that one, we have 1.697. It's less than 2, right? So we can conclude, therefore, that we can reject the null hypothesis. And by the way, remember, before rejecting it, first see if the signs correspond. So you're looking at the t-value sign. It's positive there. Does this correspond with your expectation? Yes, we are expecting it to be positive, right? And then look at this one now. Let's have a look at this one now. So we are going to change in accordance with what we are saying later, but let's first run a conclusion on what I came up with here. So 6.697, right? This one seems like it's greater than, right? It's greater than 1.2. So if it's greater than 1.2, what did we say? We said we actually fail to reject, right? So by failing to reject, we are saying it might be statistically insignificant, right? That's what we basically mean there, right? Suppose now we want to do a two-directional test, right? So a two-directional test, what would be our null hypothesis? Therefore, we are expecting that this is not equal to, right? This is not equal to. So in this instance, we are simply going to be putting that equal sign and then canceling that equal sign there, right? So which means that we are basically expecting, oh, sorry, no, we're not supposed to put that there. So if we are saying not sure there, not sure, right? Then basically, the one thing that we are basically saying is not gonna work out, right? Remember, for our null hypothesis, we are going for what is not expected, right? So what is not expected is for this to be equal to 0, right? For this to be equal to 0. So in other words, when we are saying there is no relationship at all, so we've included that beta coefficient for the reason that we think there is a relationship. The only thing that we don't know is what kind of relationship is it, right? So which means it can either be this here is a negative relationship because we are saying our beta is less than 0, but again, it can be a positive relationship. It can be a positive relationship. So which is where our beta is greater than 0. All right. So now because we are dealing with a two-directional test, then we are going to make an adjustment to that there to make it apply differently at the bottom. So here now we are going to have a two-directional test, right? This is still the same, right? So the only difference is going to be the value there. So let's see where we get our value now. So we are coming back to the table now, right? So in terms of now we are doing a two-sided test, right? And then our level of significance is 5%. So we are looking at this on column number 1, 2, 3. So we go down there to 5%. Degrees of freedom is 3. So it's going to be our value, our critical value is going to be 2.042. So you take that 2.042, that's what's going to apply now on that one there. So we replace that value simply because it's now a two-sided one. Now let's look at the absolute values now. So we calculated and then we got our, what did we get? We got our 1.2, but the critical value is 0.42. So we simply still come up with the same conclusion that we do not include these, or maybe we shouldn't have. It's not statistically significant, right? That's what this basically means. All right, so because of time, let's discuss this one here, right? Let's discuss on a different question paper. I think I have another question paper here that I had. All right. So on the question paper now, typically we will get this here, right? And then we are testing for significance at the same level. So again, you might want to find out what our degrees of freedom is. So how do we get our degrees of freedom? So you said it's n minus k minus 1, right? What is your n? Your n is 33, sorry, 33, it's given there. Then k is the number of x variables, right? So how many do we have? 1, 2, 3, 4. So it's going to be 4, right? And then minus 1 again, which is for the constant. So it's 33 minus 4 minus 1, which is basically 33 minus 5, right? 33 minus 5, I think it's 28. So we are dealing with 28 degrees of freedom here, right? So now we need to calculate our t values. So how to calculate t values? So normally at the bottom here, what you're finding at the bottom here, this is an equivalent of this here, right? What you find at the bottom is an equivalent of standard error here. So this is where they put the standard error. And then these are your coefficients there. 50.2, 0.68, 0.66, right? So remember how we're calculating our t values. 50.2 divided by 8.2, 0 minus 0.68 divided by 0.26, 0.66 divided by 0.24, etc. Right? And then again, to get to that, to get to a reasonable conclusion, we also want to check the expected signs, right? So what is CHIC here, our dependent variable? The annual per capita kilograms of chicken consumed in a country. And then it's the log per capita of disposable real income. So what relationship would you expect there? So obviously, if people's real income go up, we expect that their consumption of chicken could also go up, right? But remember again, if you are in a position you like to analyze, you might want to see what kind of a product chicken is, because sometimes these can move in opposite directions, right? Consumption and income, right? Sometimes your income increases and your consumption of other things decreases, right? And then the average annual real wholesale price of chicken. So if the price goes up, we expect consumption to go down. So a negative relationship there. So mind you, I'm also checking here with the signs, right? Seeing if it corresponds. And then the average real wholesale price of fish, right, in rand. So what effect does the price of fish have on chicken? So let's assume for starters these are, right, let's assume that these are substitutes. Let's just say these are substitutes. So if, unless chicken is more of very good staple food, yes. Let's say fish and chicken are substitutes, right? Let's say fish and chicken are substitutes. So if the price of fish goes up, we expect that the consumption of chicken is going to go up. So hence we can expect a positive relationship there, right? I don't expect these to be complements, fish and chicken. No, I doubt. And then the dummy variable there, which is the variable, which a dummy variable equal to 1 for the years in which there was bird flu, a bird flu health scare, and then 0 otherwise. So it looks like this one is fine. It's negative, right? It's negative. I expect a negative relationship. I mean, if it's 1 there when there was a bird flu, then it means that consumption is supposed to go down when there's a bird flu scare. No one would want to consume in those circumstances. So we'll therefore make it negative. All right, now, given 28 as our degrees of freedom and then 5% significance, then we can simply go and check there. It's a one-directional test, right? There's nothing that we are not sure of there. So a one-directional test. So we go to 28 degrees of freedom, then I believe it's 1.701. That one would correspond with 5% there for a one-sided. So which means our values there are being measured by 1.071. So let's just calculate 1 and then see. Okay, let's just calculate 1 and then see how it goes. So, right, so for the first one, it was 50. So it's simply 50.02 divided by 8.2. So this is 6 point something. You can already see that it's bigger than our 1 point something that we got for the critical value. So what do? We fail to reject the null hypothesis. So we do these calculations and then we weigh it against them. So again, after checking in terms of our expected signs, right? So this one would be 0.68 divided by 0.26. Then we measure that against the critical value, etc. Then you simply get your 10 marks on that one, right? So next up, we are going to have a session during the week, maybe on Tuesday or so, but I'll see. It's going to be a later session, which is after 8. Right. So what we're going to be doing now on that one, I want us to deal with the ANOVA test, right? The ANOVA test, which is going to be overall significance, which is our F test. So we are going to be dealing with the F test and then identifying a possible maybe how we can improve regressions, because we normally get that. So on the textbook before the session, please go through. I was hoping we are going to do a couple of questions here, but it's fine. We will see. So this is on chapter 5. So you are simply perusing through chapter 5 there. All right. I do not know if we have any questions before we conclude the session.